This is PLC and BMS, written by me, Sean LeGuay. Here's the legal stuff. Firstly, what's in a name? Now, a PLC is a small controller that controls things. It's a small computer that controls. People tell me that PLC is the term that's used in industry. Well, PLC is a PLC. It doesn't really matter where you're using it. It doesn't matter if you're using it to control your conveyor belt or to control your building or to control your car. It's still a PLC. People say that there is another beast called a DDC, and a DDC is different. In actual fact, DDC means direct digital control. DDC is the verb. It's the what a PLC does. So it's the same thing really, and the terms can effectively be used interchangeably. A building management system, now this is when we get PLCs and we use them to control a building. Typically we have lots of small controllers and they're all talking to each other on a network. That allows us to do all sorts of fun things and optimize the building. As the years have gone by, the building management system became more and more complicated and we bolted more and more things on it. Originally we just used to do the aircon, but soon it was controlling everything in the building, at which point we started calling it a building automation system. So, what sort of things do these building automation systems do now? Well, they do the aircon. That's the first things they do. They alarm. They send alarms out. They monitor the electricity usage inside the building and the main electricity coming in. They control the lights. They interface to the fire control system. They also now control the access, the doors, and at the end of the month or the end of the week or the end of the year they can produce reports so that people can see just how well their building is performing. So the first thing they started off doing was controlling the air conditioning. Because it was a big networked system and everything was talking to everything else, the air handling units could talk to the rooms and ask the rooms, well, how are you doing? What's the temperature in your room? And they could alter the way they behaved depending on how the rooms were controlling or whether or not the room was actually occupied or not. Then the air handlers could talk to the chillers, and the chillers would start when the air handlers needed cold water, or the boilers would start when the air handlers needed hot water. And then the chillers could talk to the cooling tower, and the cooling tower would start when the chillers had condenser water to deal with. Before we had everything talking to everything else, what used to happen is everything used to run all of the time. Another thing we can do is monitor electricity. Not only the electricity coming into the building, but the electricity used by individual tenants within that building, so that we can bill them correctly. We can also look at the electricity and see if it's about to go above a tariff threshold. We can switch off non-essential systems. We normally do this in a round-robin way, what they call rolling blackouts in some countries. We can talk to the lights. We can use occupancy sensors to see if there's anybody in the room, and if there isn't, we'll turn the lights out and we'll turn the aircon off. How many times have you driven past buildings where all the lights are blazing all weekend and you just know there's nobody in those offices? We can give out alarms, not just local alarms to the people in the building, but we can also send out SMS alarms, so that if it's an ice cream warehouse, for instance, and the refrigerators break down, we can send out an alarm to the nearest refrigeration engineer and get in there and fix it before all the ice cream melts. We can interface with the fire system. This allows us to set the air handlers into the appropriate modes when fires occur, so that we can pressurize staircases and pressurize the rooms adjacent to the fire. We can give out reports. This allows us to see how each tenant is behaving, to see if changes we're making are going to be saving money, and of course saving money means reducing carbon output and, well, saving the planet. We can do access control. We can monitor who's coming in and out of our building or our facility, and we can open or close doors to the appropriate person. This can also interface with the fire system, so that in the event of a fire everybody goes to an evacuation point and presents their ID card, and the system automatically takes a log of who's missing. It can also be used to monitor who is and isn't in the building, so that we can check people who are claiming, for instance, overtime. Signals going in and out of a control system are of 4 types. They're on-off signals. Things that are on-off we call digital. They only have 2 states, on-off. Could be on-off, start-stop, locked-unlocked, alarm normal, 2 states. We call them digital. If they're coming in, we call them digital inputs, DI. If they're going out, for instance to contactors, to relays, solenoids, we call them digital outputs, DO. Continuous signals, such as temperatures, which can be anything from, say, 0 to 100 degrees Celsius, or flows, which can be 0 to 200 litres a minute, or pressures, which can be 0 to 400 pascals. Things that are continuous, we call those analog. That's a historical thing. So, continuous signals, which are coming in, we call analog input, AI. And continuous signals which are going out, we call analog output, AO. This is summarizing that. These are the DIs, the DOs, AIs and AOs. Collectively, we call these things points. And we compare control systems by comparing the number of points they have. So that I might say, oh, this building's got 10,000 points, that building's got 5,000 points. Or in a specification, it'll say the control system needs to have 10,000 points with 20% redundancy. Now, the sort of things that we can do, since we have a networked, unified control system, with the air conditioning, we can optimize things. This is how we normally start a building. We want to have it nice and comfortable. This is a cold morning. We want to have it nice and comfortable for 8 o'clock when the people come in. So what we typically used to do is we would start the building at 6 o'clock in the morning, so that the temperature would come up and it would be nicely the right temperature for 8 o'clock when the people arrive. This is what we can do if we have a networked control system. We monitor the outside air temperature, we monitor the temperature in the building, and then instead of starting the building at 6 o'clock, we'll start it at precisely the right time so that it's nearly perfect at 8 o'clock when the people arrive. Because, let's be honest, they won't have taken their coats and jackets off until about 8:30, so it doesn't need to be perfect at 8 o'clock. Now, this will save a good hour's air conditioning every day. Another thing we can do is when we stop it. My building ceases to be occupied, it loses occupancy at 5 o'clock in the evening. So traditionally what we did was we ran all the air conditioning right up until 5 o'clock in the evening. And then we switched it off and the temperature came up. With a network system, we can do this, optimize stop. We continue to run the air conditioning units, but we turn the big plant, the chillers and the boilers, we turn that off early. So we might turn the chillers off at 4:30. It's going to be dependent on the outside air temperature. So we'll turn the chillers off at 4:30 and the temperature in the building will start to rise, so that by 5 o'clock it's a little bit warm. But that's alright, people are leaving anyway. This can save another half an hour of running the major plant, another huge cost saving. Lunchtimes. What I can do at lunchtimes, what I normally do at lunchtimes in most buildings, is just run it through. If I turn the air conditioning off at lunchtime, then it might get so uncomfortably hot in the room that it takes too long to recover after lunch. So what I do instead is I use setbacks. Instead of running the room at 22, I might go for 24, just during the lunch period. So that the air conditioning carries on running, but just backs off a bit, so that after lunch it doesn't take too long to recover. Another little cost saving. And that's all I have for this very short video. Thank you for listening.